So in today's lesson, we're going to look at deriving further trig identities and using them to work through some proofs. So we're going to work through theory covered in exercise 6D. So here, if we take our identity, so we're always going to start with our sine squared x plus cos squared x equals 1. So taking that, we're going to divide, first of all, divide each term through by cos squared x. So that will give me sine squared x over cos squared x plus, we've got our cos squared x. We're going to divide that by cos squared x. And we know that that equals 1, but we've got to divide that through by cos squared x as well. Simplifying this, well, we know sine squared over cos squared x will give us tan squared x. Cos squared over cos squared is 1, and 1 over cos squared x is sec squared x. So there we have derived our new identity. Similarly, if we take our original identity, so I'm going to take sine squared x plus cos squared x equal to 1. And now I'm going to divide through by each term by sine squared x. So that will give me sine squared x over sine squared x plus cos squared x over sine squared x equals 1 over sine squared x. So I've divided each term through by sine squared x. Now sine squared over sine squared equals 1. Cos squared x over sine squared x is cot squared x. And 1 over sine squared x is cosec squared x. Just run out of room there. So that will equal cosec squared x. And that gives us our other identity. Okay. Now, in some questions, you may be asked to prove that 1 plus tan squared x can be written as sec squared x equals sec squared x. So in that case, you would have to recognise that, okay, we'll take the original identity, sine squared x plus cos squared x. You know that you want it to equal 1, so we're going to divide this equal 1. So we're going to divide through by cos squared x because we want tan squared x, which is sine squared over cos squared. So we'll divide each of our terms by cos squared x to derive the identity. Now you'll get to know these identities really quickly, but you do need to be able to prove them. You may well get asked to do that. So again here, I'm asked to prove the identity tan squared theta minus cot squared theta equals sec theta minus cosec theta multiplied by sec theta plus cosec theta. So I'm going to take the right hand side. You can try taking the left hand side if you like. But if I expand those brackets, I will get sec squared theta plus sec theta cosec theta minus sec theta cosec theta minus cosec squared theta. Now using my identities, and I should really write these down, I can say that sec squared theta equals 1 plus tan squared theta and cosec squared theta is equal to 1 plus cot squared theta. Now in an exam you should always write down which identities you are using or subbing in instead, rewriting. So that will give me sec squared theta. So that will become 1 plus tan squared theta. Sec squared, the sec theta cosec theta minus sec theta cosec cancels out. So minus cosec squared theta is 1 plus cot squared theta. Simplify my bracket, just taking into account that we're subtracting a bracket here. So we have minus 1, minus and plus is a minus cot squared theta. 1 minus 1 cancels out, so that simplifies down to give me tan squared theta minus cot squared theta as required. Therefore, left-hand side equals right-hand side. We have proved the identity. Now here we're on to a proof type of question. Now in an exam, the first thing I would do somewhere on a piece of paper would be to write out my identities. So I would write out my sine squared x plus cos squared x equals 1. Dividing through by sine squared x, I know that would give me 1 plus cot squared x. And 1 over sine squared x is cosec squared x. And dividing through by cos squared x would give me tan squared x plus 1 equals sec squared x. So I would write out those identities at the beginning of the exam and have them down somewhere because you are going to use them. So here we've been asked to prove the identity 2 minus tan squared theta equals 2 sec squared theta minus 3 tan squared theta. So I'm going to take the right hand side. So if I take the right hand side, so I've got 2 sec squared theta minus 3 tan squared theta. Now I can see that on the left hand side I want to write this in just in terms of tan theta. So I can see from this identity here that tan squared theta plus 1 equals sec squared theta. So therefore, this will become 2 tan squared theta plus 1 minus 3 tan squared theta. Expanding the bracket will give 2 tan squared theta plus 2 minus 3 tan squared theta, which will simplify down to give me 2 tan squared minus 3 tan squared is minus 1 tan squared theta. So therefore my left hand side equals my right hand side. It's been proved. Now we've said in a previous YouTube video, so for exercise 6C, that in trigonometry you'll either get solve questions or prove questions. So we've gone through a couple of proofs. Now we're going to look at solving some equations, and the first thing I would do is have a look here and I think, okay, we've got it in terms of pi, so we're going to make sure we're solving this in radians, so you need to check your calculator. I would then look at my equation. I've been asked to solve an equation of 2 variables. We've got it in terms of cot theta, cot x and cosec x. So I need to write that out just in one variable. So if I write out my question, so I've got 5 cot squared x minus 2 cosec x plus 2 equals 0. Now I do know an identity. I know it's easy to forget what the identities are, so it doesn't take a minute or so just to write down your sine squared x plus cos squared x equals 1. Now we want to work out what cot squared x equals. So To get cot squared, I would divide through by sine squared x. So that will give me 1. Cos squared over sine squared is cot squared x. And 1 over sine squared is cosec squared x. Okay, so rearranging this identity here, I could therefore write, okay, well, cot squared x is going to be cos squared x minus 1. Then I've got my minus 2 cosec x plus 2 equals 0. And I can see I'm going to end up with some sort of quadratic to solve. So I have 5 cosec squared x minus 5 minus 2 cosec x plus 2 equals 0. 5 cosec squared x minus 5 plus 2 will give me minus 3. And I've got minus 2 cosec x here, and that will equal 0. And at this point, we know we're going to factorise, but you could actually just use your calculator to solve it. So putting that in a calculator, I'll get cosec x equals 1, so 1 over sine x equals 1. So that means that sine x will be 1. And reciprocating this will give me sine x equals minus 5 over 3. Now that's smaller than minus 1, so they're no valid, so that solution's not going to work. So I'm interested in when sine x equals 1. We're looking in the range of x between 0 and 2 pi. Therefore, my only solution is going to be that x equals pi over 2. Here we're going back to another proof type of question. This one's taken from the textbook. Now I'm going to take the left-hand side. So cosec to the power 4 theta could be written as cosec squared theta all squared. And cot to the power 4 theta can be written as cot squared theta all squared. And straight away we can see we've got the difference of 2 squares. Always crops up, you just got to be able to recognise it. Okay, so if I take that, I can then factorise that. This means that this can be written as cosec squared theta minus cot squared theta in one bracket, and in the other bracket I will have cosec squared theta plus cot squared theta in the second brackets. Now using these identities here, I can take the first bracket, so cosec squared theta I can write as 1 plus cot squared theta. Then I've got to minus cot squared theta. And my second bracket will be, I'll leave as cosec squared theta plus cot squared theta. Now my first bracket will just become 1, so I'm left with cosec squared theta plus cot squared theta. Now, using my reciprocal functions here, I'm just going to move my page up a little bit. Then I know that cosec squared x I can write as 1 over sine squared x. I'm trying to, because I can see on the right hand side I've got an expression in in terms of cos squared x, that's what I'm trying to get to. And cot squared can be written as cos squared theta over sine squared theta. And if I simplify that, I've got the same denominator, so that'll give me 1 plus cos squared theta over sine squared theta. And the identity, if I know that sine squared theta plus cos squared theta equals 1, then this will become 1 plus cos squared theta, and sine squared theta equals 1 minus cos squared theta. Proved. So I've now proved, I'm going to use green this time, that the left-hand side equals the right-hand side. Quite a nicely equated. There are probably other ways of doing it, but we want to try and find the easiest way with the shortest number of steps, because then you're less likely to make a silly mistake. And it all hinges on this at the beginning, recognising the difference of two squares. So here we're going to try another solving type of question, and as with any equation, when you're asked to solve an equation, you've got to make sure you've got it all in just the one variable. And here I can see I've got a mixture of cosec squared theta and cot theta. So I need to write that in just, so we've just got one term in the equation, one variable. So I know that from the identity, again, I always start off with my sine squared theta plus cos squared theta equal to 1. I need cosec squared theta. So if I divide through by sine squared theta, I will get 1 plus cot squared theta equals 1 over sine squared theta, which equals cosec squared theta. Just run out of room there. Okay, so I can now write the original question just in terms of cot theta. So for cosec squared theta, we could write as 4, 1 plus cot squared theta. Then we have minus 9 equals cot theta. I'm going to expand the brackets. That will give me 4 plus 4 cot squared theta minus 9 equals cot theta. Rearranging the equation will give me 4 cot squared theta minus cot theta, then 4 minus 9 will give me minus 5, and that will equal 0. Now I can factorise that quite easily. You can use a calculator if you like at this stage, or you might just want to show you working out, but you can use a calculator to get your solutions. So 4 cot theta minus 5, and that will give us cot theta plus 1 equal to 0. And from here I can say either cot theta will equal 5 over 4 or cot theta will equal minus 1. So cot theta we know is tan theta, 1 over tan theta. If I reciprocate both sides, that will give me tan theta, just flipping that fraction round, will give me 4 over 5, or I will have tan theta equal to minus 1. And then I can solve each of these within the given range. Now we're looking for all angles of theta between 0 and 360. So solving in the normal way. So tan theta for the first one, 4/5, will be in those two quadrants. So that will give me 38.7. And this acute angle 38.7. So I've got 38.7 and 218.7. It should really be 3 significant figures, but anyway. And tan theta equals -1 will be in those 2 quadrants. So we will get, that'll be 45 degrees is the acute angle. So my 2 angles will be 135 degrees and 315. And there we are, we've found all the angles within the given range. So make sure you find them all. Think in terms of the graph or your cast diagram. So here we have an example taken from an exam paper in 2013. Solve for theta between 0 and 2 pi. So here, first thing when you read the question, you think, yes, we're working in radians. And we've been asked to solve 3 sec squared theta plus 3 sec theta equals 2 tan squared theta. So again, we've got to write that with just one variable. So I would write down, if I was doing this, I would think, okay, I need to remember my identities. So I know that sine squared theta plus cos squared theta equals 1. Dividing through by cos squared theta will give me tan squared theta plus 1 equals sec squared theta. So I can write my original question in terms of sec theta. So therefore I can say that 3 sec squared theta plus 3 sec theta equals 2 tan squared theta, so that will be 2 times sec squared theta minus 1. Expanding my brackets, so would give me 2 sec squared theta minus 2. Rearranging it, because the only way to solve an equation is to equate it, get it equal to 0 first. So 3 sec squared theta minus 2 sec squared theta will leave me with just sec squared theta plus 3 sec theta plus 2 equals 0. Now it says you must show all your working out, so I need to factorise that. So that will give me sec theta plus 2 sec theta plus 1 equals 0. So sec theta equals minus 2. So reciprocating both, that will give me cos theta equals minus a half, or sec theta equals minus 1. So cos theta equals minus 1. Making a bit more room here. So therefore my solutions here, cos theta equals minus a half. So I'm looking in those 2 quadrants. So my values for theta will be 2 pi over 3. And 4 pi over 3. And here my values of x equals minus 1. That will give me theta equals pi. So there are my 3 solutions within the given range, all working out shown. Again for this, we've got another exam question. It says solve for x between 0 and 2 pi. So again, radians. 2 cosec squared theta plus cot x equals 5. So I know that my identity, so I know that sine squared theta plus cos squared theta equals 1. So dividing through by sine squared theta will give me 1 plus cot squared theta equals cosec squared theta. So if I've got 2 cosec squared x plus cot x equals 5, then 2 cosec squared x can be written as 1 plus cot squared x plus cot x equals 5. And I'm going to work towards, I'm going to have a quadratic which I can then hopefully factorise and solve. So expanding the bracket, 2 plus 2 cot squared x plus cot x minus 5 will equal 0. 2 cot squared x plus cot x, 2 minus 5 minus 3 will equal 0. Factorising will give me 2 cot x plus 3 in one bracket and cot x minus 1 in the other bracket. So cot x will equal minus 3 over 2, or cot x will equal 1. So cot x is 1 over tan x, so reciprocating both will give me tan x equals minus 2/3, or tan x is equal to 1. And solving for x within the given range, so in the first one we know that tan is negative in these two quadrants, so that will give me x, and we're working in radians, so my 4 solutions are going to be x equals 2.55. It does say to 3 significant figures, 5.70, 0.785 and 3.93. So they're my 4 solutions to 3 significant figures. So it's really important to read the question carefully. Look at what we're measuring. We're measuring in radians. We want our answer to 3 significant figures. Watch your signs and you should be fine. So that's all we need to cover on this. So the thing with proofs and identities, you need to know the identities, and there is no quick solution to this. The only way to get better is to do lots of practice. So the more practice you get, the better, and the more chances you are to experience and go through the type of questions that could come up. Okay? And there are little tricks that you can use, and the more questions you do, the more familiar you will be with them. So on that, so I would like you to work through all the questions in exercise 6D. The more questions you do, the better, and the more likely you are to come across the little tricks that you can use when proving identities.